Hello my dear students, this is P. Venkateshwarlu, PGT Physics. Yesterday we completed the entire chapter, that is gravitation. Chapter number 8 completed. Coming to chapter number 9, mechanical properties of solids. So what is the chapter, my dear children? Mechanical properties of matter or solids. Mechanical properties of solids. Chapter number 9. Chapter number 9. Mechanical properties of solids. Okay, understand my children? Mechanical properties of solids. This is chapter number 9. Okay. See here, mechanical properties of solids. Before going to discuss about the content, we need to discuss about what is solid. So what is solid, my children? Solid means which is a material. Solid means which is a material which have definite shape and volume. Definite shape and volume. Understand? So solid is a material which have definite shape and volume. Okay. So even though the importance of solid in engineering field, we can use this type of solids to construct buildings, bridges and electric poles, railway tracks, etc. The importance of solid is to construct buildings, to construct bridges and to construct electric poles, railway tracks and etc. Okay. See here, so the solid having some property if any force applying on the solids. Okay, so if the solids are deformed with the application of load or any force. Deformed means what, my children? So consider a balloon or anything, so we can apply force, so the shape will changes, the shape and volume will changes. This we can say deformed. Okay, understand? So if we can take big hammer, we are applied to load or force on the object, it means what happens? The shape will changes. Understand? We can say this is deformed. Deformed. Example, see here, this is a balloon or sphere. We are applying force with a hammer. With hammer, what happens? The shape will changes like this. Okay. Like force is applied here and we can get this shape. So this phenomenon we can say deformation. Deformation. Understand? Understand? Deformation. So how much force is needed to the shape and volume of the body is changes? That force is called deforming force. Okay. Deforming force means deforming is a type of force which is used to change the shape of the body, or the minimum force is required to change the shape of your body. We can say that is deforming force. Understand, my children? Okay. See here, because of the importance of solids, we can use this solids in constructing a buildings. We know that. And in this chapter, we have to discuss about the properties of solids under the influence of external load. Means the properties of a solids under the influence of external force or load. Means we are applying force on the solids, some property is there. What are the properties? Means elasticity, elasticity, plasticity, stress, strain. Okay, so these are the topics, these are the properties, these are the properties of solids we need to discuss about in this chapter. What is the chapter name, my children? Mechanical properties of solids. So we know that the definition of solids and the definition of deforming force. Okay, now first we need to discuss about that elastic body and elasticity. First one, elastic body. Elastic body. Okay, elastic body, which is defined as a body regains its original shape and size. Regains original shape and size after removal of deforming force. Understand? See here, elastic body means elastic body which is defined as a body or a material which regains its original shape and size by the removal of deforming force. Understand? See, consider one elastic rubber. Okay, so we can stretch it. Okay, the elastic rubber will the length will increase after removal of external force. Means so the elastic nature regains after some time. Understand? This type of bodies we can say elastic bodies. Understand? Consider a balloon or any material. So we are applying force. After removal of this force, we can observe same size and same shape of a body. This type of bodies we can say elastic bodies. So what are the example of elastic bodies? Quartz fiber. Okay, so quartz fiber, ivory ball, phosphor branch, etc. PHOSPER. Quartz fiber, ivory ball, phosphor branch, which are the example of which are the examples of elastic bodies. Which are the examples of what, my children? Elastic body. Okay, so what is elasticity? Elastic body completed. Then what is elasticity? Elasticity, my children. Elasticity is a property of solids. Elasticity, it is a property of solids. Okay, by virtue of it becoming its original shape and size. It is the property of matter, it is the property of solid in which the body regains its original shape and size. Okay, this property we can say elasticity. Elasticity is a property of solids in which by virtue the body regains original shape and size after removal of this deforming force. Okay, and within the elastic limit. Within the elastic limit means after the elastic limit the body will not regains its original shape and size. Yes. Coming to plastic body. Plastic body and plasticity. Plastic body. How we can define plastic body? How we can define plastic body? So plastic body is a material, okay, so in which in plastic material it will not regains its original shape and size by the removal of deforming force. So if we are applying on a force, means if we are applying force on the plastic material, the plastic materials are deformed. Okay, we can remove this deforming force. The plastic body will not regain its original shape and size. This type of bodies we can say plastic bodies. Okay, example for plastic body: putty and paraffin wax. Putty and paraffin wax. Putty, paraffin, wax and mud. These are the examples of plastic body. So and another one is the quartz. Okay, what are the examples? Putty, paraffin wax, mud, quartz. So what is the meaning of plastic body? Plastic body is a material in which after removal of deforming force, this type of materials will not regain its original shape and size. Okay, understand? So next, plasticity. Plasticity. Plasticity, it is the nature or it is the property of material in which after removal of external deforming force, the body will not regain its original shape and size. Okay, so plasticity is the nature or it is the property of solids in which the body will not regain its original shape and size, my children. Okay, so we know that the examples of plastic bodies are putty, paraffin wax, mud and quartz. Understand, my children? Yes. Next, stress. Next we are going to discuss about stress. Next we are going to discuss about stress. Okay, understand? Now, so what is stress, my children? According to physics, deforming force acting per unit area is called stress. Okay, see here, consider a body. Suppose consider a body, we are applying force. Okay, so after applying force, the body changes its shape somewhat like this. Understand? By the application of force, the body will change its shape. Understand? So this force we can say deforming force. So what is deforming force, my children? So deforming force, it is not different type of force. Deforming force, it is the minimum force is required to change the shape of the body. Understand? So that we can say deforming force. Understand, my children? So here what happened? We are applying force and the body size will change. In this case, we consider some area. Okay. Here what happened? Deforming force acting per unit area is called stress. Stress is defined as It is defined as deforming force acting per surface area or area. Deforming force per unit area or area of cross section. Okay, so this deforming force, it is denoted F, and area of cross section, it is denoted A. Okay, normal force, we can say indirectly this is normal force. What is normal force? A force is applied normally to the surface is called normal force. Understand? So normal force per unit area of cross section or deforming force per unit area of cross section. So force per unit area. Okay, stress which is equal to force per unit area. Force per unit area. Understand, my children? Coming to units and dimensions of stress. Units and dimensions of stress. Units. Okay. So coming to SI system of international. So what is the SI unit of force? Yes, Newton. What is the SI unit of area? Meter square. Coming to CGS. In CGS, Newton we can written as a dyne per centimeter square. Dyne per centimeter square. Understand? So this Newton we have to write kilogram meter per second square per meter square. Okay, how we can write dimension formula, my children? Dimension formula for force and dimension formula for area. Dimension formula for force m power 1, L power 1, T power minus 2 divided by area. Dimensions of area L power 2. Rearrange this. L power 1, L power 1 gets cancelled. M power 1, L power minus 1. This L power 1 we can take in numerator. L power minus 1, T power minus 2. Okay, understand? So this is dimension formula. So by observing this unit which is analogous to unit of pressure, okay, Pascal. Understand? So this we can say Pascal. Okay, so here the units of pressure and the units of stress both are same, but the definition is different. Okay, understand, my children? So what is stress, my children? Yes, deforming force or normal force per unit cross section area is called stress. Okay, stress is equal to force per unit area. So SI units of stress is Newton per meter square. For CGS system, dyne per centimeter square. Dimension formula m power 1, L power minus 1, T power minus 2. Okay, understand, my children? Yes. Coming to different types of stress, my children. Different types of stress. Types of stress. Okay, so here stress we can categorize by 3 types. What are the means? Stress we can differentiate in 3 types. They are normal or longitudinal stress. Normal or longitudinal. Next one, tangential or sharing stress. Tangential or sharing stress. And third one, volume or bulk stress. Volume or bulk stress. Volume or bulk stress. Volume or bulk stress. So coming to normal or longitudinal stress. Okay. So what are the types of stress? 3 types. Normal or longitudinal stress, and the second one tangential or sharing stress, third one hydraulic or bulk stress. Understand, friends? So now we are going to discuss about first one. So what is the normal or longitudinal stress. Okay, so by discussing this normal or longitudinal stress, we need to discuss about rod. Okay, so it is rod. Only we can consider here length. Understand my children? Here we are applying normal force per unit area, means like this. We are applying force like this. Okay, original length is L. After application of force, the body will change its length. It's become like this. This it is denoted L plus delta L. Okay, length increases. Length increases. Understand? Understand my children? Which is defined as normal force per unit area. So normal stress or longitudinal stress, we have to define force per unit area. Force per unit area. Understand? Okay. Force acting to different surfaces up and down. Here, after that, the length of the rod increases. That is L plus delta L. Okay. Understand? Here, force acting per unit area. Force acting per unit area is called normal or longitudinal stress. Okay. So for here, we have to take along the length. Understand my children? Normal force per unit area for we can consider a rod. Okay. So this we can say normal or longitudinal stress. And coming to next one, tangential or sharing stress. Second one, tangential or sharing stress. It is the second type of stress. So how we can define this type of stress means consider a object like this. Okay. So the force we are applying tangentially like this. Here we can apply force above the body. Okay, understand? So what happened? So the body shape will changes. Okay, understand how like means? I will show you. Okay, understand? We are applying tangentially force or steering force. Okay, how we can apply this type of force means we can apply the force above the surface. Understand? Here we need not to apply force above the surface. We have to apply like this. Understand? So we can observe this part A. This is A dash. Okay, understand? So this it is denoted delta x. Delta x. Understand? So delta x amount of displacement occur where the force is applied. Understand my children? This type of force acting per unit area is called sharing stress or tangential stress. So for this tangential stress, which is equal to force per unit area, force acting per unit area, my children. Okay. Understand my children? At last we have to discuss about this hydraulic or bulk stress. Okay, volume or bulk or hydraulic stress. Third one, at last we have to discuss about volume stress or bulk stress or hydraulic stress. Okay, which is defined as a force acting per unit area. But in the case of this volume or bulk or hydraulic stress, so we have to discuss about one complete volume of the body. See here, we can consider this type of body. So we are applying force uniformly in all directions. Understand? So after applying force, okay, we can observe the size of the body will decreases. Okay, so not shape is same, but the size will decreases. Understand? So after applying this type of deforming force, so we can get the final value V minus delta V. Here the decreasing value, how much it is decreasing, we can denote it delta V. Okay. So after applying of this deforming force in uniform force is applying all directions, we can get the hydraulic stress. Okay, so these are the types of stress, my children.